In this video, we will be covering two different methods of solving a quadratic equation, completing the square and using the quadratic formula. We'll get into some examples at the end. These methods are purely mechanical, meaning it's just a series of steps you have to remember. So let's get right to it. Starting with completing the square. This is the original method that the Babylonians first used to solve quadratic equations thousands of years ago. Given the quadratic equation ax squared plus bx plus c equals 0, our goal is to remove the x squared term and get an equation in terms of x only. So what we do is to perform a few transformations to get from an unsolvable form of this into a final solvable form of this. This equation is now solvable because you can move all the constants to one side and square root them to get an equation in terms of x only. So what are the steps? How do we get here? Starting from the equation ax squared plus bx plus c equals 0, step 1 is we want to remove the a term so that x squared can stand on its own. We do this by dividing the whole equation by a. So it will look something like this. So the first a is removed from ax squared, and then you take bx, you divide it by a to get b over ax, and then do the same for c to get c over a. The right hand side of the equation remains the same because 0 divided by anything is still 0. Then I want you to ignore the constant for the time being and focus on x squared plus b over ax, which is highlighted in the top right hand side here. How do we simplify x squared plus b over ax? What we want to do is to get something in which we only have one unknown. So I want you to look at this equation over here. X plus y all squared equals to x squared plus 2xy plus y squared. We want to make what's up there in yellow look as close to the right hand side of this equation as possible. What can we do to achieve that? Well, we can't change x because x is a common unknown in both equations. So let's try changing y to see what happens. We can see that if we let y equals to b over 2a, the equation becomes x plus b over 2a all squared equals x squared, that remains the same, b over ax. This comes from taking 2 multiplied by b over 2a, so the 2's cancel and we are left with b over a, and then lastly added by b over 2a bracket squared. Do you notice that the first half of this equation on the right hand side looks very similar to the yellow highlights above? In fact, they are exactly the same. So then we just need to rearrange to get x squared plus b over ax, that's what's in yellow highlights on top here, equals to x plus b over 2a bracket squared minus b over 2a bracket squared. Some of you might ask, why bother going through this transformation? It still looks quite complicated. What's special about this is that there are now no more x squared terms. We only have one x on this side. That makes our job a lot easier. Since everything else in the equation are constants, we know what b over 2a is, and we know what c over a is. We can rearrange and solve it like any other equation. We just need to replace the yellow highlighted portion, x squared plus b over ax, with x plus b over 2a bracket squared minus bracket b over 2a squared to get our required result. Now everything else in the equation are constants. We know what b over 2a is, we know what c is, and we know what a is. So we just need to sub everything into the equation and rearrange to solve it just like any other equation. So we move what we know to the right hand side and then square root it. The only thing to always remember to do here is when you square root the constants, always remember that the answer can either be positive or negative. This is simply because 2 squared and negative 2 squared are both equal to 4. So you need to account for both possibilities in searching for your answer. That's all. This may all look like mathematical hocus pocus to you, so here's a diagram for you to visualize why this works. For simplicity of notation, we are just going to consider the equation x squared plus bx plus c equals 0, because you can get the solution for ax squared plus bx plus c equals 0 simply by dividing through by a. First, we rearrange our equation to get all the unknowns on one side. X squared plus bx equals negative c. Then I want you to imagine a small square with side length x. We join two rectangles of length b over 2 to either side of the square. Note that these have an area of b over 2x because its width is the same as x. When you add up these areas, you get x squared plus bx. This is the left-hand side of our equation from step 1. Then look, the length of our L-shaped object is b over 2 plus x, and its width is also b over 2 plus x. They are the same. So to complete the square, we fill up the remaining space with a square whose length is b over 2. So from this picture, you can see that there are two ways of calculating the area of the L-shaped object. The first way is by calculating the area of the small square and two rectangles. Or, the other way is by calculating the area of the whole figure and subtract the area of the large square. They are the same. That is why we call it completing the square, because you are essentially adding in this red square and then removing it later. So now let's move on to the quadratic formula. I would say that this is probably the most convenient method of finding roots of quadratic equations because it gives us the solution directly in the form of just one formula. And that formula is x equals negative b plus minus square root of b squared minus 4ac divided by 2a. This is the final form of the solution to the method of completing the square actually. So both of them yield exactly the same results. However, it's still important to learn how to complete the square because that way of expressing a quadratic equation has many uses in future chapters. Now, if you don't believe that using the quadratic formula and completing the square are the same, just watch this. We start with the end result of completing the square. X plus b over 2a squared minus b over 2a squared plus c over a equals 0. Then we rearrange to put all the constants to one side, as I mentioned earlier. We take the square roots of both sides, remembering again to add in the plus minus sign, and then we move the constant b over 2a from the left-hand side to the right-hand side, while at the same time making everything inside the square root to be one fraction. So we just have to multiply c by 4a. That's how we get b squared minus 4ac over 4a squared. Then notice that 4a squared is a perfect square, so you can take it out of the square root and leave 2a there instead. And since both terms in this equation now have a common denominator, we can express it as one fraction. Now, let's go through some examples. Let's take 12x squared plus 16x minus 3 equals to 0. We want to find the two values of x that satisfy this equation. So our a is 12, our b is 16, and our c is negative 3. Using the quadratic formula, you just have to plug in the values of a, b, and c into the formula. So b is negative 16 plus minus square root of 16 squared, which is 256, and then you minus 4 times a, which is 12, times c, which is negative 3. That gives you 400, and then you divide it by 2 times a, which is 24. That gives you an answer of 1 over 6 or negative 3 over 2. Remember that since there is a plus minus sign, once we get to this stage, we need to split our answer into two. One to account for the situation where 20 is a positive, and one to account for the situation where this 20 is a negative. That's how we get our two answers. Similarly, by completing the square, remembering the final result of our completing the square exercise before, we also just need to plug in the values of a, b, and c into this formula to get this. So we can simplify all the constants to get to a result which is x plus 2 over 3 bracket squared minus 4 over 9 minus 1 over 4 equals to 0. Then we move the constants to the right hand side. We square root them to get plus minus 5 over 6. And since we've square rooted both sides, the square on top here on the left hand side goes away. And then we move 2 over 3 from the left hand side to the right hand side as our final step. Remember again that we have to split up our solutions into the case where 5 over 6 is positive and the case where 5 over 6 is negative. So the results are the same, 1 over 6 or negative 3 over 2. Let's go for a second example. Negative 2x squared minus 18x plus 9 equals to 0. How do we do this using the quadratic formula? Remember the quadratic formula, x equals to negative b plus minus square root of b squared minus 4ac over 2a. Here our a is negative 2, b is negative 18, and c is 9. We just plug those numbers in to get 18 plus minus square root of 396 over negative 4. Then remember again that when we take the square root, to account for the cases where square root of 396 is positive and square root of 396 is negative. In this case, the square root of 396 is 19.8997. Then you take 18 plus 19.8997, divide by negative 4 to get negative 9.4749. Or you take 18 minus 19.8997, divide by negative 4 to get 0.4749. By completing the square, the result is the same. And remember again what the final form of completing the square is. X plus b over 2a all squared minus b over 2a squared plus c over a equals to 0. I'll say it again. X plus b over 2a or bracket squared minus b over 2a squared plus c over a equals to 0. So we plug in the numbers for a, b, and c, simplify to get x plus 4.5 bracket squared minus 20.25 minus 4.5 equals to 0. And then we move everything that we know to the right hand side to get x plus 4.5 all squared equals to 24.75. Square rooting both sides, remembering to put the plus minus sign. We then do our final step of moving 4.5 from the left hand side to the right hand side to get 0.4749 or negative 9.4749. And that concludes the video. Remember to stay curious and always follow your dreams. I'll see you in the next video.